Hello everyone. Today we are going to talk about binomial and multinomial distribution of CSE230 discrete mathematics. Let's talk about binomial distribution first. So what is the expansion of x plus y to the power 4? We know that the rth term of any expansion is ncr x to the power n minus r into y to the power r. So the zeroth term would be 4cr, as the highest power is 4 here, so ncr would be 4c0, x to the power n minus r would be 4 minus 0, that is 4, and y to the power 0. The first term would be 4c1 x to the power 4 minus 1 y to the power 1, and the next term would be 4c2 x to the power 4 minus 2 and y to the power 2. The next term would be 4c3 x to the power 4 minus 3 and y to the power 3, and the last term would be 4c4 y to the power 4. So if I ask, then what is the coefficient of x square and y square in the expansion of x plus 4 to the power y? First you have to expand it, as I have done it earlier. And what is the coefficient of x square and y square here? 4c2. The next question is, what is the coefficient of x to the power 12 y to the power 13 in the expansion of x plus y to the power 25? Now remember, we always know the rth term is what is the power of y, right? So here the power of y is 13. So the coefficient of x to the power 12 and y to the power 13 would be ncr, which is 25c 13. 13 would be the power of y. So we can calculate it. The coefficient is this big number, right? So the next question is, what is the coefficient of x cube y square in the expansion of 2x minus 3y to the power 5? So we can change it to 2x plus the bracket of minus 3y and the whole to the power 5, right? So we have to find the what is the power of what is the coefficient of x plus x to the power 3 and y square, right? So we can always just we can expand it and do it on our own, or we can just find, right, 5c2 to the power cube and minus 3 to the power y. Why 2 to the 2 cube here? Because the coefficient of x here is 2 and the coefficient of y here is minus 3. That is why we need to calculate the term where the power of y is 2, that is 5c2 and 2 to the power 3 and minus 3 to the power 2. So now the question is, student takes a test with 10 multiple choice questions. Since he has never been to class, he has to choose at random for the 4 possible answers. What is the probability that she will get exactly 3 right? All right. So we have the number. The number of trials is here is 10. That is n. Since she is guessing the probability and she is taking one answer out of 4 possible answers, the probability of getting one right is 1 upon 4. As she need to get exactly 3 right, the success k here is 3 and failure n minus k is 7. So what is the probability of getting 3 right is? So first is ncr, that is 10c3 p to the power r, that is 1 upon 4 to the power 3, and 1 minus p to the power n minus r. 1 minus p is 1 minus 1 upon 4, that is 3 upon 4 to the power 10 minus 3, that is 7. A football team wins each week with probability of 0.6 and loses with probability of 0.4. If we suppose that outcome of their 10 games are independent, what is the probability that they will win exactly 8 games? So the number of trial here is 10, number of success here is 8, probability is 0.6, and 1 minus probability is 0.4, right? So NCR, that is 10C8, p to the power success here is r, that is p to the power 8, and 0.4 to the power 10 minus 8, that is 2. In the country of Bangladesh, Ifat is a dumb computer scientist, but sometimes he makes useful programs too. So this time he somehow made a program which can predict if a person is COVID-19 infected or not with a success rate of 45. So as I have told already, he is dumb, but he helps me making these slides now. Okay, so now if we test 15% with Ifat's program, what is the probability that he will get exactly 7 infected people correctly? So number of trial here is 15. The R, that is the success, is 7 times. The probability is 0.45. So 1 minus probability is 0.55. NCR is 15C7. P to the power R is 0.45 to the power 7. 1 minus P to the power N minus R is 1 minus 0.5, 1 minus 0.45, that is 0.55 to the power N minus R, that is 15 minus 7 is equal to then 8. So do not use his program because you won't get more than 0.2% of success, right? Now let's talk about multinomial. Consider a die with 1 painted on 3 sides, 2 painted on 2 sides, and 3 painted on 1 side. That is, it will have 1 in 3 sides, the number 2 in 2 sides, and the number 3 in just 1 side. If we roll the die 10 times, what is the probability that we get 5 ones, 3 twos, and 2 threes? That is, what is the probability that you get the number 1 5 times, the number 2 3 times, and the number 3 2 times, right? So we are rolling the die 10 times. That is, so the probability of getting these things are 10 factorial divided by 5 factorial, 3 factorial, and 2 factorial. Why? Because we want 5 ones, 3 twos, and 2 threes. That is why 5 factorial, 3 factorial, and 2 factorial. And the probability of getting 1 is 1/2, that is 1/2 to the power 5. And the probability of getting 2 is 1/3, that is 1/3 to the power 3. And the probability of getting 3 is 1/6, so 1/6 to the power 2. A baseball player gets a hit with probability of 0.3 and a walk with probability of 1 and out with probability of 0.6. If he bats 4 times during a game and we assume that the outcomes are independent, what is the probability that he will get 1 hit, 1 walk, and 2 outs? The number of trial here is 4, K is 3, the category is 1, 1, and 2. So 4 factorial divided by 1 factorial, 1 factorial, and 2 factorial. The probability of getting 1 hit is 0.3, so 0.3 to the power 1. The probability of getting 1 walk is 0.1, so 0.1 to the power 1, and probability of getting out is 0.6, and the number of times we want him out is twice, so 0.6 to the power 2. The output of a machine is graded excellent 70% of the time, good 20% of the time, and defective 10% of the time. What is the probability that a sample size 15 has 10 excellent, 3 good, and 2 defective items? So total number of trial in here is 15. We want 3 good and we want 10 excellent, 3 good, and 2 defective items. So 15 factorial divided by 10 factorial, 3 factorial, and 2 factorial. The probability of excellent is 0.7. We want it to be excellent 10 times, so 0.7 to the power 10. The probability of getting good is 0.2. We want it to be good 3 times, that is why 0.2 to the power 3. And the probability of getting defective is 0.1. We want it to be defective twice, that is 0.1 to the power 2. Thank you. I hope these examples help you. Do the problems from the book and let us know if you have any problems.